So, let us first discuss Doolittle method. What is Doolittle method? If A can be decomposed in the form L into U with L as a unit lower triangular matrix, then the system Ax is equal to B can be solved by using forward substitution method followed by backward substitution. So, let us illustrate this Doolittle method for a simple system Ax is equal to B, where A is a 3 by 3 matrix. So, X is a 3 by 1 vector and B is a 3 by 1 vector. The procedure is the same whatever be the value of n is when you are given an n cross n square matrix A. So, if A is a 3 cross 3 matrix and A has a decomposition of the form L into U, where L is a lower triangular matrix, but we would like to use Doolittle method. So, L is a unit lower triangular matrix. So, A has entries A11, A12, A13, A21, A22, A23, A31, A32, A33. This is equal to L into U. We would like to apply Doolittle method, in which L is a unit lower triangular matrix. So, it has entries 1 on the diagonal. It is a lower triangular matrix. So, the other entries will be L11 in the second row, L31, L32 below the diagonal on the third row, and the other entries will be 0. So, you observe that this L is a unit lower triangular matrix with entries only lying below the diagonal, and U is an upper triangular matrix. So, U11, U12, U13, 0, U22, U23, 0, 0, U33. So, let us multiply this and write down. So, the first row into the first column will give you U11, first row second column U12, first row third column will give you U13. Then the second row into first column L21 U11 plus 1 into 0 plus 0 into 0. Then second row into the second column will give you L21 into U12 plus 1 into U22. Second row into the third column will give you L21 into U13 plus 1 into U23. Now, third row into the first column will give you L31 into U11 plus L32 into 0 plus 1 into 0. Then third row into the second column will give you L31 U12 plus L32 into U22. And finally, the third row into the third column will give you L31 into U13 plus L32 into U23 plus 1 into U33. So, we have obtained the product of L into U, and that must be equal to the entries here in the matrix A. When do we say that the two matrices are equal? When the ijth entry in this matrix is the same as the ijth entry in the matrix A. So, we equate the ijth entry for I is equal to 1, 2, 3, j is equal to 1, 2, 3 and obtain the unknowns which appear here. What are the unknowns? There are 1, 2, 3 unknowns appearing in the lower triangular matrix, and there are 3 plus 2 plus 1. So, 6 unknowns appearing in the upper triangular matrix. Totally there are 9 unknowns, and we have 9 entries here which can be equated to the corresponding entries in the A matrix which are known to us. So, we will be in a position to obtain these unknowns which appear on this matrix L into U. And you observe that you first equate U11 to A11. So, U11 is determined. Then you use the next equation as L21 U11 is A21. Because U11 is determined, L21 is determined. So, we first determine this, then we determine this. Now, equate L31 U11 to A31. U11 is determined. So, this will immediately give you L31. So, what did you do? You obtained the first entry in the upper triangular matrix and you completed the first column entries in the lower triangular matrix by making use of these. Now, you move over to U12, that is A12, that is immediate. So, you get U12 and then U13 is A13. So, determine that also. Now, you move over to this, right. You know U12, just now you computed, L21 is already obtained and therefore, you can compute what U22 is by equating this entry to A22 and continue this way, namely determine the entries in the first row of the upper triangular matrix, in the first column of the lower triangular matrix. Then go to determining the entries in the second row of upper triangular matrix and go to the entries in the second column of the lower triangular matrix, and finally, the entry in the third row here, and that completes determining all the unknowns which appear on the right hand side. And so, we have with us the matrix L and the matrix U. So, let us take an example and then illustrate this procedure. So, let us consider the matrix A given by this, and let us try to factorize A in the form L into U, where L is a unit lower triangular matrix and U is an upper triangular matrix. So, now that all that is needed has been done, I directly equate this to U11, U12, U13, L21 U11, L21 U12 plus L22, L21 U13 plus U23, then L31 U11, L31 U12 plus L32 U22, and finally, the entry here is L31 U13 plus L32 U23 plus U33. So, what should we do? We first determine the first row here by equating it to this. So, that immediately tells us U11 is 2, U12 is 3, U13 is 1. So, these are determined. Now, I move over to the column here. So, L21 U11 is 1. Therefore, L21 into 2 is 1. So, L21 is half. Then I have L31 into U11 is 3. So, L31 into U11 is 2 and that is 3, and therefore, L31 is 3 by 2. So, we have determined these entries in the first column of the L matrix. We now move on to determining the entries on the second row here, namely determining the entries on the second row of the upper triangular matrix. So, we have L21 U12 plus U22 is equal to 2. L21 is known, U12 is known, U22 is unknown. So, this gives you U22 as 2 minus 3 by 2, and so U22 is half. So, you have determined this entry in the second row. Now, we equate this L21 into U13 plus U23 equal to 3. In this, L21 is half, U13 is 1 and U23 is unknown. So, this gives you U23 to be 3 minus half, and so it is 5 by 2. And therefore, this entry is determined. So, the unknowns in the second row of upper triangular matrix have been computed. What should we do now? We should try to determine now the unknown in the second column of the lower triangular matrix, namely compute what is L32. So, we take this entry and equate that to the value 1 here. L31 is 3 by 2, U12 is 3, L32 is what we want, U22 has been computed and that must be equal to 1. So, 9 by 2 plus half of L32 is 1. So, 9 plus L32 will be 2, and so L32 is minus 7. So, we have computed the entry in the second column of the lower triangular matrix. The only unknown that remains is the entry in the third row of the upper triangular matrix. So, we equate this entry to the corresponding value in the A matrix. So, L31 U13 plus L32 U23 plus U33 must be equal to 2. L31 is 3 by 2, U13 is 1, L32 is computed by us just now, and that is minus 7 into U23, that is computed as 5 by 2, and U33 is not known, and that must be equal to 2. This gives you therefore U33 as 2 plus 35 by 2 minus 3 by 2. So, 2 plus 35 minus 3, 32 by 2, so 16. So, U33 is 18. So, the unknown in the last row of the upper triangular matrix has also been computed. I hope the procedure is clear. When you apply Doolittle method and decompose A in the form L into U with L as a unit lower triangular matrix, then follow these steps systematically to compute the entries in L and U. Start with computing entries on the first row of the upper triangular matrix, step 1. Step 2, compute the unknowns in the first column of the lower triangular matrix. Then the entries which are unknowns in the second row of the upper triangular matrix. At the fourth step, compute the entry in the second column of the lower triangular matrix. Then finally, move over to computing the entry in the third row of the upper triangular matrix. So, we now have all these values. So, we write down what A is or how A can be factored in the form L into U. We will write down the matrix in the form A is equal to L into U. 1, L21 is half, L31 is 3 by 2, then 0, 0, 1, 0, L32 is minus 7, 1. So, that is our L. We write down U, U11 that is 2, U12 3, U13 is 1. It is an upper triangular matrix. So, 0, U22 that is half, and then U23 5 by 2. Then we have 0, 0, U33 and that is 18. So, A has an LU decomposition of the form with L as a unit lower triangular matrix and U given by these entries. Now that we have decomposed A in the form A is equal to LU, let us solve the system of equations in which A is a coefficient matrix. Suppose say we are asked to solve the system Ax is equal to B with B as 9, 6, 8. Then A is LU into X is equal to B. I set Ux to be equal to Z, and therefore, I have to solve the system Lz equal to B. So, I write down the matrix L which has entries 1 0 0, half 1 0, 3 by 2, minus 7 1. Let us take Z to be a vector with components Z1, Z2, Z3, and the right hand side is B and that is 9, 6, 8. So, we have a system in which the coefficient matrix is a lower triangular matrix. So, we can solve this system by forward substitution. What is my first equation? 1 into Z1 equal to 9. So, immediately Z1 is obtained. What does the second equation give you? Half into Z1 plus 1 into Z2 is equal to 6. So, Z1 is 9. So, 9 by 2 plus Z2 is 6, and therefore, this gives you Z2 as 6 minus 9 by 2. So, it is going to be 3 by 2. Now, I move to the last equation. What does it give? It gives you 3 by 2 into Z1 minus 7 Z2 plus Z3 equal to 8. We already have Z1 and Z2 with us. So, 3 by 2 into Z1 is 9 minus 7 into Z2 is 3 by 2 plus Z3 is 8. So, therefore, Z3 will be 8 plus 21 by 2 minus 27 by 2. So, 8 minus 6 by 2. So, it is going to be 5. So, Z3 is 5. So, the vector Z1 having components Z1, Z2, Z3 is given by 9, 3 by 2 and then 5. So, vector Z is now known, and therefore, we can use this system Ux is equal to Z and solve for what X is. Write down the system Ux is equal to Z. What is U? 2, 3, 1, 0, half, 5 by 2, 0, 0, 18. X has components x1, x2, x3, and the right hand side vector z has components 9, 3 by 2, 5. What do? We see that we have a system whose coefficient matrix is an upper triangular matrix. So, we employ back substitution and solve this system. So, we start from the last equation and we observe that we have 18 x 3 as 5. So, x 3 is 5 by 18. Then half of x 2 plus 5 by 2 x 3 is 3 by 2. So, cancelling 2 throughout, x 2 is 3 minus 5 x 3. So, it is 3 minus 5 into 5 by 18. So, 3 minus 25 by 18. So, 54 minus 25 by 18. So, 29 by 18, that is x 2. Now that we have x 2, we move to the first equation, which gives us 2 x 1 plus 3 x 2 plus x 3 is 9. X 1 is an unknown to be determined. So, 3 times x 2 is 29 by 18 plus x 3, which is 5 by 18, and this must be equal to 9. This gives you 2 x 1 as 9 minus 5 by 18 minus 29 by 6, and therefore, x 1 will be equal to half of 9 minus 5 by 18 minus 29 by 6. So, let us simplify this and obtain what x 1 is. And we see that x 1 is equal to 35 by 18. So, the solution is given by vector x equal to So, the solution is given by vector x having components x 1, x 2, x 3, and the values are given here. So, we have been able to solve the system of equations A x is equal to b using Doolittle's factorization method. So, you try to see whether your computed solution is correct by substituting the solution in the given system. So, you must have 2 times x 1 plus 3 times x 2 plus x 3 should be equal to 9, and you obtained x 1 as 35 by 18. So, 70 by 18 plus 3 x 2. So, 87 by 18 plus x 3. So, 5 by 18, and that is your left hand side. Check whether this gives you 9. And this is 9. So, that is equal to the right hand side. So, when you verify that your solution is correct, then you can be confident that your calculations are correct. So, it is always better that you ensure that at each step of your computation, your computed result is a correct result. So, let us now move over to the next method, namely Crout's method. In Crout's method, A has to be factored in the form L into U with U as a unit upper triangular matrix. The procedure is the same. So, we will quickly demonstrate how Crout's method can be used to solve a system of equations. So, we shall consider an example and then work out the details, and that will explain to us how one can solve the system of equations using Crout's method. So, let us solve the system 5 minus 2 1, 7 1 minus 5, 3 7 4 multiplied by x1 x2 x3 equal to 4 8 10 by Crout's method. So, in this we have to decompose A in the form L into U. L is a lower triangular matrix and U is a unit upper triangular matrix. So, on the diagonal we have entries as 1. So, this will be U12, U13 and this is 0, U23, 0, 0, 1. That is the upper triangular matrix. And L is a lower triangular matrix. So, L11, L21, L22, 0, L31, L32, L33. So, L is a lower triangular matrix. And what is A? A is given to be the matrix with entries 5 minus 2 1, 7 1 minus 5, 3 7 and 4, and this must be equal to the product of these two matrices. So, let us multiply these two matrices and write down the entries. So, first row into first column. So, L11, then L11 U12 plus 0 into 1 plus 0 into 1, L11 U13 plus 0 into this plus 0 into 1. Then second row into first column, L21 into 1 plus 0 plus 0, L21 into U12 plus L22 plus 0 into 0. Then L21 into U13 plus L22 into U23 plus 0 into 1. Then the third row into the first column. So, L31 into 1 plus 0 into L32 plus 0 into L33. Then third row into the second column. So, L31 U12 plus L32 into 1 plus 0, and finally L31 into U13 plus L32 into U23 plus L33. So, now we equate the corresponding entries in both the matrices. So, that will give you L11 to be 5, L21 to be 7 and L31 to be 3. So, we have determined the first column elements in the lower triangular matrix. So, we move over to determining the first row elements which are unknowns in the upper triangular matrix. So, what should we do? We should equate L11 into U12 to be minus 2. Just now we computed L11. So, 5U12 is minus 2. So, U12 is minus 2 by 5. So, I move over to the next entry because that will determine U13, which is in the first row of the upper triangular matrix. So, that gives you L11 U13 to be 1. L11 is 5, and so we have U13 to be 1 by 5. Having determined the unknowns in the first row of upper triangular matrix, we should move to the unknowns in the second column of the lower triangular matrix. And therefore, I make use of these two and equate the corresponding values here. So, that will give me L21 into U12 plus L22 to be equal to 1. Do I know L21? Yes, 7. What about U12? It is computed as minus 2 by 5. What about L22? That is what I am trying to determine, and that must be equal to 1. So, L22 is 1 plus 14 by 5, and so it is 19 by 5. Then we move over to this L31 into U12 plus L32 is equal to the corresponding entry, which is 7. I know what is L31 and I also know U12, which is minus 2 by 5, but I do not know what is L32. So, that gives you L32 to be 7 plus 6 by 5. So, 41 by 5. So, we have determined the unknowns in the second column of the lower triangular matrix. So, we move to the unknowns in the second row of the upper triangular matrix. So, we have to equate this entry to the corresponding entry in the A matrix. That gives you L21 into U13 plus L22 into U23, and so equate this to minus 5. So, in this L21 is known as 7, U13 is 1 by 5, L22 is 19 by 5, the unknown is U23. So, 19 by 5 into U23 is minus 5 minus 7 by 5. So, minus 32 by 5, and therefore, U23 is minus 32 by 19. So, we have determined the unknown in the second row of the upper triangular matrix. So, I have to move to the third column of the lower triangular matrix and determine the unknown which appears there, namely L33. And so, I make use of this entry in the product and equate it to the corresponding entry here. This will give me L31 into U13 plus L32 U23 plus L33 is 4. L31 is 3, U13 is 1 by 5, L32 is 41 by 5, U23 is minus 32 by 19, L33 is an unknown to be determined. So, therefore, L33 is 4 minus 3 by 5 plus 41 into 32 divided by 5 into 19. We simplify this and write down the value of L33. It turns out to be 327 by 19. So, all the unknowns have been computed and we write down the matrix L and matrix U. L has entries L11 5 0 0, L21 is 7, L22 is 19 by 5 and then 0, L31 is 3, L32 turns out to be 41 by 5 and L33 is 327 by 19. We also write down U. U has entries 1, U12 which is minus 2 by 5, U13 is 1 by 5 and then 0, 1, U23 is minus 32 by 19. The last row in U has entries as 0 0 1. So, we now know the matrix L and the matrix U. So, at this stage I would suggest that you multiply the two matrices L and U and check that you get the elements of the given matrix A. So, that computations up to this stage can be checked and verified. Now that we have the two matrices L and U and we are asked to solve the system Ax is equal to B, let us work out the details by first using forward substitution followed by backward substitution. So, the system Ax is equal to B will now become Lux is equal to B and we set Ux as Z and that will give you Lz equal to B. So, I first have to solve for the unknown vector Z and then substitute here to get the unknown vector x. So, what is my system Lz equal to B? L has components 5 0 0, 7, 19 by 5, 0, 3, 41 by 5 and 327 by 19. That has to be multiplied by the unknown vector having components z1, z2, z3 and that is equal to B. B has components 4, 8 and 10. So, use forward substitution and write down the solution. The first equation is 5z1 equal to 4. So, z1 is 4 by 5. The second equation is 7z1 plus 19 by 5 z2 is 8. So, 19 by 5 z2 is 8 minus 7 into z1 that is 4 by 5. So, 8 minus 28 by 5. So, 40 minus 28. So, 12 by 5 is z. This gives z2 to be 12 by 5 into 5 by 19. So, it is 12 by 19. And now we use the third equation which gives 3z1 plus 41 by 5 z2 plus 327 by 19 into z3 equal to 10. So, 3 into z1 is 4 by 5 plus 41 by 5 into z2 is 12 by 19 plus 327 by 19 into z3 must be 10. So, therefore, you can compute z3 from this equation which gives you 10 minus 12 by 5 minus 41 into 12 by 5 into 19 and so Z3 will be 19 by 327 times. Simplify this to obtain what Z3 is, 46 by 327. So, now that you have the components of Z vector, you can solve the system Ux is equal to Z. The system is given by Ux is equal to Z, where U is 1 minus 2 by 5, 1 by 5, 0, 1 minus 32 by 19, 0, 0, 1 into unknown vector x1, x2, x3 is z1, z2, z3, and we have already computed z1, z2, z3 as 4 by 5, 12 by 19 and 46 by 327. So, use backward substitution method and obtain the values of the unknowns x1, x2, x3. First you will obtain x3. 1 into x3 is 46 by 27, 327. So, x3 is 46 by 327. Then first next equation gives you 1 into x2 minus 32 by 19 into x3 is 12 by 19. So, x2 is 12 by 19 plus 32 by 19 into x3, which is 46 by 327. And the first equation gives you 1 into x1, that is x1 is equal to 4 by 5, then plus 2 by 5 into x2, and x2 is what you have computed here. Then minus 1 by 5 into x3, that is 46 by 327. So, simplify and you have the solution for the unknown vector x, and you have used Crout's method to solve this system, where you have decomposed A in the form L into U, where U is a unit upper triangular matrix. And once you have determined L and U, you have used the forward substitution method followed by backward substitution procedure to determine the unknown, which is the vector x. So, we have demonstrated how we can obtain the solution of a system of equations by decomposition methods, namely Doolittle method and Crout's method. In the next class, we shall discuss how we can solve this by Cholesky's method if you are given a real symmetric positive definite matrix, and then move on to other direct methods such as Gauss elimination and Gauss-Jordan techniques. We will continue with our discussion on direct methods for solving system of equations in the next class.